Our final section in plant physiology is about plant nutrition, nutrients, and a bit about soils. Here we go. Plants, like all living things, require food, in this case, plant food or plant nutrients. Plant foods are called essential elements or plant nutrients. The three main ones we think about are nitrogen, phosphorus, and potassium, indicated by the scientific symbols N, P, and K. There are two major food groups for plants, macronutrients and micronutrients. Macronutrients are those needed in relatively large amounts like NPK and calcium, others. Micronutrients are needed in very, very small amounts, things like molybdenum, boron, iron. It's important to know, however, that any essential element that is in short supply is important. A couple of elements that we don't often think about because they're available so easily from the air and water are carbon, oxygen, and hydrogen. We don't think about these when we think about fertilizer. But in fact, there's more carbon in the plant than any other element. That's a test question, by the way. Just like human foods that list the ingredients on the package, fertilizer bags will list how much of each nutrient is available. A fertilizer labeled 22,314, for example, is made up of 22% nitrogen, 3% phosphorus, and 14% potassium. N, P, and K are always listed in this order. This is probably a fertilizer used for lawns because it has a lot of nitrogen, which makes the plants green. You wouldn't want to use this on vegetables. And which is the most important nutrient? Well, it's whichever one is missing that it becomes most important. Usually it's nitrogen because it leaches in the soil. Phosphorus and potassium can be limiting, but any of the microelements could also be limiting in some soils. Let's take a look at some of these essential elements. The first macronutrient we'll look at is nitrogen. The important thing about nitrogen to know is that it makes plants green. Anytime you see any kind of yellowing in the plant, it may be a nitrogen deficiency. Nitrogen is often in short supply because in the soil it can leach out and not be available to the plant. When plants become deficient or don't have quite enough phosphorus, they quite often turn purple. Here you can see a little bit of purpling in this corn leaf here. Phosphorus is, there's lots of phosphorus in the soil, but it's often in a form that's not available to plants, and this may limit plant growth. Potassium is rarely deficient in most garden soils, at least those that are composted well. But if the plant doesn't get enough potassium, it often gets this scorched appearance on the edge of the leaf. Calcium is another macronutrient that may be quite available in the soil, but plants have a difficult time taking it up during periods of dry weather or water stress. This is the cause of a common problem called blossom end rot. As you can see here on this tomato or on these squashes and cucumbers, you often get blossom end rot. In mid-July, lots of gardeners lose tomatoes to blossom end rot. The answer is not to apply more calcium because the soil probably has calcium. The answer is to water the plants adequately. We're only going to look at a couple of micronutrients as examples. Iron is one. It's needed in very small amounts, but if it's unavailable, it can cause problems. It can be applied in commercial fertilizer and will often be included in lawn foods. But most gardens get plenty of micronutrients if you apply organic matter in the form of compost. When it's deficient, you get this yellow striping appearance in corn. Most gardeners don't spend a lot of time thinking about deficiencies or what plants look like when they don't have enough nutrients, but rather spend their time thinking about how to add adequate nutrients, manures, chemical fertilizers, composts, among the best. One of the best ways to provide adequate plant nutrition to vegetables is to build soil organic matter. Green manures can build soil organic matter by building fertility. Here we've got a crop of buckwheat with the white flowers, which will be turned down into the soil, will decay and provide organic matter and fertilizers for next year. And here we have a crop of Sudan grass. The problem, of course, with green manures is it takes up space where you could be growing vegetables. But if you've got a large garden, it's really a wonderful way of building soil organic matter, building soil health, and providing nutrition to the following year's vegetable crop. A good, healthy soil will have lots of earthworms. Here, a farmer is showing one of my students how worms really get busy when he puts down a cardboard mulch, cover the cardboard with manure and straw. The worms eat the soil, eat the cardboard, eat the straw, and release nutrients everywhere they go. They can really help improve soil health and build organic matter once they get started. Chickens are a great source of nitrogen fertilizer. Chicken droppings have lots of nitrogen in them. Here you have chickens that are grown on a garden after the crop is harvested, fertilizes the soil for next year. Dairy cows and beef cattle will provide a lot more manure, but they're a bit difficult to manage in your backyard. Here's some chickens in my own backyard eating bugs after the strawberries have been harvested. I pick the strawberries, weed whack the plants down, and put the chickens in to eat the bugs and manure the garden for next year's crop. Yeah, I raise chickens. I've even raised turkeys in my backyard. I don't live on a farm. You can see here the five or six turkeys there in the pen fertilizing my lawn for next year. I believe the best way to provide adequate nutrition to your vegetable garden is with organic manures, green plants, green manures, and lots and lots and lots of compost. This builds soil fertility, builds soil health, and builds this earthworm population to create a healthy soil system. Everybody should be building soil with compost. Was a way of recycling old yard waste, kitchen scraps, and building soil, having a healthy garden. Composting speeds up a natural decay process, and creating a compost pile or a bin requires just a little bit of work and paying attention to the various factors of air, water, how much compost material are in there, and temperature. The composting process is done by microorganisms, bacteria, and fungi. And where do they come from? Well, they come from a natural, healthy soil. You don't need to add bacteria. They'll be around. If you build it, they will come. In fact, it's impossible to keep them out. Bacteria and fungi are present in all soil, all leaves, food scraps, manure, and in finished compost. Adding any of these materials will provide adequate microbes to start the composting process. If you want to add decomposers to your compost, just add a little bit of good garden soil. Small amounts of soil added to your compost from time to time will provide all the bacteria and fungi it needs to get going. Just like you, your decomposer workforce of bacteria and fungi will do the best of the balanced diet. They need a mix of high carbon materials, we'll call them browns, and high nitrogen materials, we'll call them greens. Here's an example of some of the browns: leaves and straw, newspaper, but not using the glossy print, sawdust, animal bedding. Any of this stuff has got a lot more carbon in it than nitrogen. And here are some examples of the so-called greens, which are rich in nitrogen. These materials also often are a little bit wet and soft as well. Got to mix them with the browns to make a good compost. Because of their characteristics, browns and greens each have some problems if composted exclusively on their own, but they make excellent compost when they're mixed together. Composting is an aerobic process. That means it needs air. It needs oxygen for the bacteria and the fungi to work. To get the most active and rapid composting, the pile should be turned from time to time when the temperature begins to drop or if the temperature rises above 140 degrees Fahrenheit. Most composts will heat up quite naturally if left on their own. And how do you know when the compost is done? Well, it should have a dark brown color. It's going to be crumbly, loose, kind of humus-like. You should not be able to recognize any of the original materials you started with, the leaves, the straw, the grass, the food scraps. And coarse woody materials like twigs and sticks will need to be taken out. The pile has shrunk to about one-third of its original volume when it's fully cooked. If you have a small yard or neighbors that complain about the look of your compost pile, you can certainly use one of these manufactured bins. They're kind of expensive, however. A well aerated compost won't smell at all. But if you do notice a rotten odor, go out and turn the compost, add some dry material, some browns, and cover up any kitchen scraps that are exposed. An ammonia odor is from too much nitrogen or greens. Once again, add some carbon materials and the smell should go away. A common problem, and one reason for using a bin rather than a pile, is that compost can attract raccoons, skunks, rats, and insects. Meat scraps, fatty food wastes, and foul odors are usually attract these pests. Be sure and bury and mix the food scraps into your pile. Don't leave them on top. If animals are a problem, you can use an animal-proof bin or a net fencing around the pile. Dealing with these few problems is really worthwhile, however. Composts have a tremendous beneficial effect on soil health. Improves organic matter, attracts earthworms to the garden, stimulates microorganisms, helps with water holding capacity, and adds nutrients. You love compost. If your problem in the soil is lack of nutrition, add compost. If the problem in your soil is it's too wet, add compost. If the problem in your soil is too dry, add compost. Moving on now to soils. Here's a definition of what soil is. I think the most important part of it is that it's a living system. Soils are alive. This lecture looks at some of its physical characteristics, the chemical characteristics of soil, as well as the biological characteristics of soil. The first of two physical characteristics is called soil texture. This is the way a soil feels. It depends on the relative proportion of various sizes of soil particles. Sandy soils are gritty and clay soils are fine particles and sometimes can feel sticky. Let's take a look at this a little bit more closely. Soil texture will depend on the relative amount of each of the three major sizes of particles, sand, silt, and clay. Sandy soils have much larger soil particles than soils with a lot of clay in it. The relative size of a sand grain to a clay grain is something like a beach ball compared to a dime. Sand, silt, and clay are the names we use to describe the various sizes of particles. Sandy soils feel gritty, silty soils feel somewhat floury, kind of soft and silky, and clay soils definitely are sticky. A good garden soil will have a mixture of sand, silt, and clay. If you have a soil with too much sand, it will tend to dry out. The solution is to add organic matter, preferably compost. If you have a soil with too much clay, it'll be too wet. The solution is to add organic matter. preferably as compost. Organic matter in this case will improve soil structure and make up for the high clay content. A well-structured soil will aggregate small clay particles and make them into larger sand-like sized particles. This improves structure. Even in a poorly textured soil with lots of clay, you can help create larger sized particles by adding organic matter. While soil texture can't change, soil structure can be improved or can be broken apart. You improve soil structure by adding organic matter, and you can destroy soil structure by rototilling or plowing or walking on it while it's wet. A soil with good structure will have good aeration between the soil aggregates. It will also hold water inside the aggregates. A poorly structured soil will collapse, as the one on the right. All the aggregates will mush together, reducing the amount of air in the soil. This can prevent roots from breathing and result in root rot. Let's move on now to soil chemistry. The most important thing to know about chemistry is pH, or the relative acidity or alkalinity of the soil. pH measures the relative proportion of hydrogen or more likely hydroxide ions in the soil. We use pH to measure acidity or alkalinity in the soil water. pH is measured on a scale of 0 to 1 to 14. Very, very low, like numbers are like battery acid or very, very acid. And oven cleaner and hair removers are very, very alkaline. Most of the time you find soils in the 6 and 7 range. Um, Normal rainwater will be a 5 or 6. Pure water will be neutral. Seawater will be slightly alkaline. This gives you a sense of the range of pH you can find in nature. Most good garden soils will be from neutral to slightly acid. Some fruits and vegetables have a very specific range in which they thrive. Most of them will do well near neutral, but there are some exceptions, such as blueberries, which prefer a more acid soil because they need lots of iron. Iron is more available at the lower pH. It's a good idea to get your garden soil tested for pH because pH affects the availability of nutrients. Most micronutrient problems are not caused by too little of the micronutrients, but too high or too low a pH. You can buy a simple soil test kit in most garden centers, and quite often master gardeners may appear at your farmer's market and will test soils for you for a couple of dollars. You don't need any test kits to measure the biological characteristics of the soil. If a soil is healthy, it'll smell healthy, it'll feel healthy. It should have lots of earthworms and organic matter. If you're concerned, add organic matter, mostly in the form of compost. Compost is the best thing you can do for your garden.